Krista Campbell. Thank you for joining us today for leveraging technology to track utility relocations. This month, the water team welcomes Arash Farajian, Frank Arellano, and Kate Jung from Toronto Water. Arash is the business support coordinator for the director's office. Frank and Kate are engineering technician technologists in the distribution and collection transit coordination group. Today, they will share their stories surrounding the efforts to track water utility relocations within a 19-kilometer heavily congested corridor as part of a light rail transit project. You're in for a treat because their presentation is great. We also have special guests Mo Torabi and John Mancuso from the Toronto Water Maintenance Group, who will be joining us for the Q&A at the end of the webinar. So be sure to submit your questions. We have a great webinar coming up. I hope you enjoy it, and we're going to let David go ahead and start us off. David?
Okay, yeah, thanks, Krista. I just wanted to talk a little bit about utility relocations in general and how GIS kind of plays a role there. And then, as Krista said, we're going to turn it over to Toronto Water, and then as always, have our Q&A session. So, looking at utility relocates, this definitely takes me back to my Colorado Springs Utilities days. But, when you look at, the challenges of utility relocates, there's just the awesome task, it's a daunting task sometimes of just making sure you have all of the infrastructure mapped. That could come in the form of hopefully, GIS or assets in your GIS, but you're going to get those CAD drawings, you're going to get those paper drawings from way back when, especially when you're doing like an underground project, of course. And then there's just all of the logistics of getting everything all lined up and the staging and coordinating with all the different folks. And then of course there's just a ton of risk involved in much of the excavation, and then just relocating the utilities themselves and the service to critical customers, and then just of course cost. Kind of hesitate, but one of our interesting things that we had in our city was roundabouts. We had an affinity to putting more roundabouts in our transportation grid in the city, and the planning departments would say, this is a great thing, and they're very aesthetically pleasing, and it helps with traffic flow, and we're gonna do that. And I'd say, well, but I have all my valves in the middle of the street intersection, and now you want to put a fountain on top of my valves. And so they're like, well, just move them all. and it was like, well, okay, who's going to pay for all this? And you all know the story, right? So we've all been there, done that. And so, utility relocates becomes an incredibly complex project, and I think you're gonna hear that from Toronto. And this clearly is happening in many places, so much so that they've really launched a discipline called subsurface utility engineering. And there are plenty of standards out there. In America, we have the American Society of Civil Engineers Standards 3802, that addresses these, utility relocates, underground utilities. Canada has their standard S250-11, and then our folks across the pond, the British Standards Institute has PAS 128, and of course there's other international standards out there that all are very prescriptive about what you need to do when you're doing subsurface utility engineering. And so again, they all kind of go through all the different things that you have to accommodate. And in looking at that, of course, ArcGIS, we've got professional grade data management analysis to help you with those utility relocates. Kind of, we mentioned the system of record. That's your, the asset registry hopefully is up to date, but guaranteed you're going to find those assets that may never have, been in the system. And so it's very important to be able to take data, out of the office into the field and bring it back to the office. So the mobility piece that comes into play, and just the analysis alone of understanding the impacts, because I'm going to be moving infrastructure, and that could change pressures, that could change, clearly it's going to change the delivery to my customer base. And then there's just all the visualization to communicate all that information, and then just simply our ability to integrate with other systems to enhance that communication, and collaboration. So there really is this professional grade technology that goes hand in hand with preparing for the utility relocate. What really struck me, and Krista mentioned that this is a great presentation, and working with the folks there in Toronto Water, it really set me back on how beautiful their story is, and they're doing that with one of our story map templates. So when I it kind of really got me thinking about this professional grade storytelling that you can do with Esri technology and the use of our story maps. And I don't know if we highlight that enough, that it's an amazing communication tool to be able to present to the public, to present to your board or council when you're trying to go up for funding. Again, a great tool to communicate projects. Because you can, highlight project photos as well as the mapping. Everyone likes to be able to, understand where this project is and what's going to, what's going to happen to me, and they can do that with many of these interactive maps. So, again, the Toronto folks use one of our story map templates and has done an amazing job. So, I want you to kind of pay attention to that presentation and know, and we'll have some links at the end. That you can do this as well, and it's I encourage you to go to our story map gallery and take a look at all the different presentations that our customers have done. You can really get lost in all the amazing stories that are out there. So anyway, just wanted to kind of set the stage that the professional grade analysis that was done in this project, and also the professional grade storytelling. So I think with that, I'm just going to go ahead and turn it over to Frank, Arash, and Kate, and let them tell their story. Guys, take it away.
All right, great. Thank you very much, David. My name is Arash. I'm here with Toronto Water. I'll start the presentation. I'll pass it on to Frank and the team to share some of their experience. So a little bit about the City of Toronto here in Canada. Some facts, some basic facts. We are approximately 630 square kilometers. That's roughly 243 square miles in size. We are, from a geographical size comparison, we're similar to the city of Chicago. Our population is roughly about 2.7 million, and we are the fourth most populous city in North America, right after Mexico City, New York City, and LA. We have North America's third largest public transit system, again after New York City and Mexico City. Our Toronto Transit Commission, also known as TTC, moved about 537 million people in 2015. The TTC average daily ridership of 2.76 million people. So as you can imagine, that requires a huge coordination when it comes to any kind of construction on our transit system. Our transit system also consists of subways, light rail, and buses. A little bit about Toronto Water. We are 100% rate supported public utility, so we don't get any tax transfers from any of levels of the government. We have approximately 3.7 million customers on drinking water and 2.8 million customers on wastewater. And the reason why we have more customers on drinking water is because we also sell water to some of our neighboring regions near the city of Toronto. Our average age for our system, for our infrastructure, is roughly about 63 years old. 23% of the system is over 90 years of age, and our state of good repair backlog is roughly about $1.4 billion. That's, if we were to convert that to today's exchange rate, that's roughly about just over $1 billion US. We consist of 6 former municipalities. During the early 2000s, these municipalities, we all came together. We amalgamated to what's known today as the City of Toronto. That information is very vital to what we're presenting today, because the different municipalities, because of elevation, we have different pressure districts. Our elevation in the City of Toronto is between 75 meters to 209 meters. The map that staff have produced here is an interactive map that you can actually play with to click on different areas to see, for example, different directional valves in different former municipalities. Whether it's you turn right to turn a valve off, or you turn left in different areas. We have roughly about 5,500 kilometers of distribution water mains, over 10,000 kilometers of collection sewer, over 500 kilometers of transmission water mains, and 400 kilometers of trunk sewers, and 65,000 valves, as well as 155,000 maintenance holes, and nearly 41,000 hydrants. A little about Toronto Water. We consist of 6 sections: distribution and collection, environmental and administration, operational support, wastewater treatment, water infrastructure management, and water treatment and supply. The picture that you see there is actually our infrastructure we got from archives from early 1900s. The section that we belong to here in distribution and collection, we are responsible for inspection, maintenance, operations, and rehab of our water and wastewater and storm system. Our jurisdiction here in distribution and collection is distribution of water system, wastewater collection system, stormwater management facilities. Some of the operational challenges that we're facing today are, amongst other, our aging infrastructure. Like I said earlier, our state of good repair backlog is over $1 billion US. Limited resiliency, former municipal boundaries, multiple pressure boundaries, and simultaneous water main shut requirements. So the first 2, the former municipal boundaries and multiple pressure boundaries, the guys, once they start to talk about their challenges of utility core relocation, they'll give you more examples, concrete examples of how that's impacting us every day. Some of our tech restrictions are existing geodatabase, as well as limitation to existing works management system. In addition to that, we have some communication issues that includes multiple Toronto Water groups that work on our infrastructure, as well as our historical records that's missing. How our existing asset management is set up is that we have digital records of our infrastructure that started back in 2001. We've created our what's known today as Toronto Water Asset Geodatabase. That was a solution that was created in-house by our Water Infrastructure Management Group, one of the 6 sections that I talked about earlier. There's a screenshot of what that looks like right below that text. Changes manually recorded on printed out maps, so that creates huge issues when it comes to going back to information when staff need it. Process for digitizing of any changes takes roughly about 24 hours to 3 years, depending on the workload that the staff have and the backlog that obviously is impacted. Temporary changes are not digitized because of the backlog, and as you can imagine, once there's new infrastructure, or there's infrastructure that we know that's missing, and we want to update it, it takes a long time for that map to get updated, so oftentimes that creates operational issues for our staff when they are on site. Manual changes on maps at construction yards are sometimes not reflected in TWAGs. So again, these are once staff see the information, they record it, like you see in that picture, manually on the maps, and many times this information doesn't find its way to our Toronto Water Asset Geodatabase. Now, a bit of a background how this all started. Back in 2010, we put a strategic plan together, and our strategic plan highlighted our plans for a 10 years plan from 2010 to 2020. In addition to our strategic plan, we also did an environmental study to see what utilities our size are doing in order to modernize their operations. One of the areas that we've highlighted during our strategic plan study we looked at sustainability and infrastructure, and in there was an element about technology and GIS initiatives, which really paved the road for many of the initiatives that we're taking today. On a very high level, without getting into too much details, some of the GIS initiatives that we started over the past couple of years, one of them include sewer flushing, as you can see in the heat map here. So we've leveraged the geospatial analysis of historical block sewer data in order to create a map to see where problem areas are when it comes to sewer issues. We've identified these hotspots, and based on that, we've prioritized the areas that needs to be targeted. We are currently in the process of creating a geometric network for all of our linear asset. The goal is to improve our customer service and evolve from planning tool to an operational system tool. This is another great example of something that we've used our GIS initiative during the frozen services 2 years ago. Again, another interactive app that you can explore. With that said, I'll pass this to Frank Arellano, who will speak about our transit expansion project team.
Thank you, Arash. So my name is Frank Arellano, and along with my counterpart Kate here, Mohammed, and Johnny, we've been with this group at different points. We joined this group at different points, but initially we were a group that was formed in 2012 and kind of had this specific mandate. Basically, in not so many words, we're told you're going to be a group that helps facilitate but also help expedite the utility relocation process and coordination for the Eglinton LRT, or it's all actually commonly referred to as the Eglinton Crosstown project. So you can see on the picture here, we've got the entire team. It's our truck behind us. So just for the purposes of this presentation, we have the very lovely Kate standing right in the middle. It's a very cold day, by the way. It's got to be like in the minus teens here. We've got Johnny next to Kate onto the left side. And we have Mohammed in the orange jumpsuit over on the right. And then you can see myself in black. So that's just to introduce you a face to the name with our group. So let's talk about a little about the Eglinton Crosstown project. This is basically what our mandate covers. So the Eglinton Crosstown project is a light rail transit line, and it's approximately about 5.3 billion Canadian dollars, or if you translate that into US, it's probably a little bit less in terms of billion. If you want to get specific, it's about approximately 19 kilometers long with a completion date of 2021. Specifically, this project traverses a very congested, very busy corridor of the city of Toronto. It's actually and it's also quite intrusive. There are several sections to this project. There are at-grade stations, at-grade stops, and then there are also underground stations. Sorry, let me correct myself. There are at-grade stops and underground stations. So there's a tunnel portion, there's an elevated portion, and also at a street level portion. So we are faced with this conundrum. Ultimately, we have a problem when you're in such a congested part of the city, and also a very old part of the city. You have many things underground, and it comes as no surprise that since we're such an old municipality, record keeping plays a role in terms of to determine what's in the ground. So when it comes to building transit, it's ultimately a very messy business. It's complicated, and there can be surprises along the way. You know, For example, you excavate and you find that, hey, that water main that we thought was in X is now in Y location. So these are kind of the things that come up from time to time. And also, as Arash was referring to earlier, existing legacy issues with our system. When it comes to when it comes to existing mapping software, for example, TWAG as we refer to it here, but also our existing as-built drawings and the storage of those as-built drawings. So to conclude, basically, the combination of the two can lead to a serious impact not only to our customers along this corridor, but also to the businesses. So what we came up with was we were basically devising a pilot project. We had, through our works management system, about approximately a decade's worth of data, and we were looking at how could we utilize this data to ameliorate our current situation when it comes to addressing any impacts that utility relocations could have on our customers. We also looked at, in help with Arash, looking at what other groups were doing in terms of Esri applications, and what I mean by other groups within our umbrella, to see how they were using different online applications to tackle their corresponding issues, and how we could use that to tackle our own issues. So we looked at GIS Online and Collector, and we were going to trial these and see exactly what could we do with them according to what data we had in our works management system to address the customer service issues. And what I mean by customer service issues, I mean, just to be specific, I don't want to get into too much detail because my counterpart Kate will get into a lot of heavy detail and numbers. It'll get interesting, I promise. But for example, we have water main break statistics, we have pressure data that we've obtained from hydrants. So just to give you a background in terms of what kind of data we're going to focus on. But also taking those applications and making it mobile in order to help our staff in the field to respond to emergency situations. For example, when you have a water main break or if there's a leak somewhere that we need to respond to. So ultimately, with this pilot project, we did have one major goal in mind, and our goal was to gather field data to help mitigate the effects of construction on our customers, as I mentioned prior. And the approach that we were going to use was utilizing spatial analysis through GIS Online to make predictions about the water main distribution system. Very important to note that for the purposes of this presentation and our group, we are only looking at the water main distribution system or small diameter mains. Anything 400 millimeters and under in most cases. At this point, I like to turn it over to my counterpart, Kate.
Thanks, Frank. So I'm just going to go through a bit of a case study where we had an issue with our water main shut. We provided a water main shut to the contractors, and what we started realizing was that we were getting a lot of breaks. So we went back and we were looking at, well, is this something that we're causing, or from the transit construction, or is this just the pipes being old? So what we did was we had data going back many years. We isolated it by the years and did a comparison and a density. So on your left, you can see the water main breaks from 2004 until 2012. And on your right, you can see the water main breaks from 2013 to 2016. And the darker areas represent basically more water main breaks. So as you can see, the Eglinton station itself is highlighted here. So before construction of the station, we saw a lot of water main breaks to the north and further west of it. But once we started doing construction, what we noticed was that water main breaks started shifting or migrating south closer to the stations. So we asked ourselves, well, what's going on? Is it because of transient pressure? So one of the things that we ended up doing was plotting up, as Frank mentioned, we had hydrant pressures throughout the years. So we plotted the pressures by year and did a temporal analysis on it. And if you focus your on this hydrant, this dot here, it's yellow, which means it's between 60 to 80 in 2003. So if I keep scrolling, what ends up happening is by 2014, this point suddenly jumps to 80 to 100 psi. So it's increasing by 20 psi. So what we ended up doing was we went to our field guys and we asked them to do a little bit of a poking around in the area. At this point, I'm going to turn it over to our field guys, John Mancuso and Mohammed Charabi, to talk a little bit about what they found in that area.
Okay, hello. When we arrived on site, we noticed that there was pressure issues. So when we did an investigation, one valve was turning right, and then the other valve next to it would be turning left. So in the field, they all should be turning in one direction, but somehow these other valves were installed. So when we updated the information on collector, it was good to know that people in the office had this information as well as the field people. In the beginning of our presentation of removing valves in a roundabout, we're doing that right now for our subway stations. So you can see on the north side of this hydrant used to be a valve, and to isolate this intersection and confirm it, we moved that valve south of the hydrant. So when I click on it, it has the information that it's been moved, and we've updated with pictures. So people can say that or see that this valve has been moved south of the hydrant now. So now it's not affecting our customers to shut this intersection down and confirm that we have the isolation. We've also done that with fire hydrants that were in the way of the subway head walls. We've moved them. Just waiting for the map to update here. So you can see the old lead was right here, and we removed the hydrant west, and yet again took picture to see where it, so people could locate this with this information that it has been moved. This app is really convenient and good to have pictures attached to it, all the information, that's how many turns on a valve or where the hydrant's located, and very easily to use, opposed to using paper. And here's Mohammed to talk about more of the app.
Hi, my name is Mohammed. I've been in the field for the last 20 years, and we were working like very hard to get the work done. But with the help of this new information, like my as before, we use, if we need information about a water service card or that, we have to call dispatch. You have to go through his cabinet full of cards and that, and the waiting time, and then get forward the information back with this collector. It's on the field. It's on your hands. Like all the information is in the palm of your hand, and it's wonderful to have out there in the field. And other things was a good point was the for locating valves, because we have snow in the winter here, and that was like time consuming, and we have to work hard to find valves at those instances or those times when there is about sometimes up to a foot of snow on the ground. And this collector give us a good tool to find these valves without harming ourselves. This is safe, and most of the time, again, when we need the information about a service location, and that's where this collector comes handy to us here And as you see up there, all my other stuff, life update, enhanced safety, and so on and so on and so on. So now I'm gonna turn it over to Frank Arellano. Thank you.
Thanks very much, John and Mo. Great job. Awesome. We're very lucky to have these two. I just want to say these two are probably the biggest reason why we're using Collector and the biggest adopters, and they've been, if anything, a huge compliment towards utilizing Collector and especially the online applications for Esri.
So in summary, and some of the benefits basically that came out of this pilot project with the implementation of these mobile Esri applications and through the use of tablets. And as Mohammed mentioned before, it reduces a lot of paper-based processes. It is much more efficient. It's easier. And you've had this feedback from our actual field staff that have been utilizing it in the field for more than a couple of months now. We're almost, I think, up to a year. It does facilitate the process of updating our existing water asset field changes in online using GIS Online. And also, it allows us to access this information over a wider variety of different devices, so not just from the desktop, but also from tablets and from our phones. Moving forward, we would like to address some of the following issues, which are the accuracy of the GPS measurements. Now, this is tied obviously to the type of hardware that you're actually using. In this case, we are using an iPad. However, we are limited to the GPS accuracy of the actual piece of hardware. Another issue that we would like to tackle is the linking of our existing water mapping software, which is TWAG, with ArcGIS Online. At this point, it is not talking to each other. Also, we would also like to look at incorporating and reducing further paper-based processes. For example, for the tracking of our actual relocation of assets, we do have a separate paper-based process right now. We refer to it as record of alterations, and we are looking at utilizing Survey 123 in order to automate that process and use the tablets to facilitate this process. So as we're coming to the end, we would like to acknowledge some people that have, contributed to this pilot project. Michael Parkin, Peter Luciani, Rashida Rangar for helping us basically learn the ins and outs of using story maps. She's fantastic. Johnny Mancuso, Mohammed Tarabi, Greg Wibbs, Tony Lippa, Joe McCallan, Mark Rogers. These are all people that form part of our team. And then Toronto Water, obviously, for funding our project too.
Thanks, guys. So we do have some questions that are coming in. I'm just going to go ahead and get started with those so we can answer a handful of them before our time is up. Let's start with Joseph's question. He wants to know if you're using any additional tools, software for pressure zone analysis.
Well, we do have data loggers that we are able to get more granular data from. So we have automatic data loggers, whereas we understand that pressure does fluctuate throughout the day and throughout the season. So with the data loggers, we're able to collect more data, but right now, because data loggers are so expensive, we only have 5 of them, but in the future, we are thinking of hooking it up. We also do have a few pressure reducing valves that are hooked up to a remote telemetry unit that we can get up to the live data from, and eventually we will be slowly moving towards getting live data and more regular collection of data.
So if I could add to that very quickly, here we started a pilot project, and we're actually in the process of purchasing roughly about 50 pressure transmitters. These are remote pressure transmitters that we're installing in the field. We're trying to find, where are the best areas to actually install these pressure transmitters, and eventually with that information we'll be able to know what our system pressure is live. Now, in addition to that, we also have our water transmission group that do have pressure transmitters, but that's mainly for transmission. For our distribution system, we're trying to install remote pressure transmitters in the next year or so, actually.
I just wanted to add that I know we mentioned the data, but specifically for Toronto Water purposes, for the water main distribution system, we're talking about small water mains. Our water main system is actually modeled on static data, so at a point in time. It is not a dynamic system. So I just wanted to mention that, yeah.
Okay, great. Next question is about your data that's being captured in the field. The audience would like to know if this is stored in the SCE or if it's in an asset management system.
If it's stored in where?
Can you say that again?
Yes, they want to know if you're storing this in your SCE or if you're linking it to SCMMS, like an asset management system of some kind.
No, so that's one of the challenges that we're facing today. It is not connected to an asset management database, and that is a challenge that we're trying to deal with currently between our IT and some of our GIS information that we have. We try to push that information to GIS if we find there's a new valve in the system that's not in TWAG that we talked about earlier, but currently the two do not link.
Mm-hmm.
Okay, thank you. Back to your use of ArcGIS for Collector, are you using a versioned environment for your updates?
If we are making changes to it, does it record as a version? Is that what you're asking?
Yes.
Yeah, so I'd have to go back to it, but I do believe that we do track if they're making changes to it. What currently on Collector, you cannot go back in, say last year this time to see what the system looked like to get different versions of it. But we do keep track of changes. Yeah.
Right now, what we do is we download the data because it's right now on the Esri cloud that the data is being stored on. So we'll download different versions, but currently, because it's not connected to our TWAG system, it's very hard for us to, unless we run a Delta, to actually know what the changes are.
Okay. So we have one about your accuracy of collecting the points. Can you comment on the accuracy of Collector and if you're using an external receiver to increase that accuracy, or what are you doing in that area?
So we actually are not using an external receiver. We are looking at possibly some alternatives to help boost the accuracy of the GPS right now, but we are right now just limited to the current piece of hardware. So whether they're using Samsung or an iPad tablet, for example.
It's a great question because at the recent conference in Orlando that Frank and I attended, we got a demo of Ready Creek, and what they do there is actually each employee that has a little puck, I think, on their jacket that actually brings them down to 1 or 3 centimeters accuracy of where they're picking up samples. In this case, it was water, river water, and we are looking at that technology as well to increase that accuracy, like Frank said, but we don't have anything.
And we do notice that this is an issue, especially where in more built-up areas. Further on the periphery of the Eglinton Crosstown line, there's a lot of open space, but when you move to Yonge and Eglinton, for example, that's a very built-up area with tall buildings. We do find that our accuracy does drop. But one thing that you will have noticed is we did have aerial views, and that helps our guys guide where exactly they should pinpoint the location of the asset. So that's a workaround that we're currently using in lieu of having actual precise GPS.
Okay, great.
Yeah, Krista, I was going to just add, to remind attendees that we do have the LEAX, Water Authority seminar that we did with Travis, and he was talking about high accuracy with Collector. So they can always go back in the meetup archives and see that presentation as well. We do get a lot of questions on the high accuracy, and at times I'm actually as we're attending a lot of the rural water shows, folks are very interested in the high accuracy, and rather than maybe some of the GPS equipment, we kind of remind them about some of the amazing base maps that folks have out there with even 6-inch color photography you know, high accuracy can be your finger on collector, right? You zoom in sufficiently with something like 1 foot or 6-inch photography, you know, you can get pretty accurate with dropping those assets with high fidelity photography as well. So, but yeah, there's references on the meetup about some of the high accuracy capabilities.
Yeah, that's
one more
true.
thing. It's interesting because you also got to recognize that the project is very dynamic. So even if you have great accuracy, it's where your bearings are and what are your markers that you're using. For example, a curb could be there one day and the curb could disappear the very next day, or the hydrant that you use to mark that a certain asset could also be relocated or completely removed, or that building was torn down. Because we are tearing down buildings, we are relocating entire structures. We relocated a 4-story building on railway tracks. So because it's so dynamic, accuracy, yes, it is important. Also at the same time, things change. So it is quite interesting.
Thanks, guys. I have a couple other questions that I think go together a little bit. So firstly, you had mentioned the maintenance group that Mo and John really embrace this technology. Are there ways or tools that you use to help them understand the technology? Was there any resistance? Basically, they want to know about buy-in from your field staff and kind of along with that, getting your non-GIS users to do this editing in Collector. What's that experience like and the transition from when you first implemented to where you are now?
Okay, hello, this is John, and a few weeks back, we had quite a bit of snow cover, and we still have some, but I was doing a main shut, and we couldn't locate a valve because it was covered in snow. So someone who came out with a paper map right beside me was trying to locate it, and I thought I'd show off with this collector and came right beside them and located it first. So I was kind of in a race, but it was between the accuracy between 2 and 5 meters, and where he was with a wand, like a metal detector wand, and his paper map, I located it within 5 minutes. But it was covered.
Story.
So a little bit of a show off, but that's what technology's doing. My kids are on the iPad all the time, so I decided to take this on and catch up with them as well.
So experiences like that, obviously that helps others on your team to embrace it and want to start using it.
Mohammed, you want to chime in?
Yes, I've been using it now for the past 6 weeks. John is my co-worker, partner at work. He's been using it now for the past 6-7 months. So he's passing the information on to me, and I'm embracing it. It's safe, like, you know, just add up to all the other technologies out there, and you have open mind, and it clicked on me like in no time. So I've been doing this for just the past 6-7 weeks, and I looked into it, and it's not that hard to embrace. Thank you.
Thank you. So I think we have time for maybe one more question. This one might be a difficult one, but there are questions about your abandoned appurtenances and how do you deal with those? Do you have legacy files, or what's your workflow for abandoning assets?
Well, okay, we'll go, I guess I'll talk about the before, and then Kate, you want to talk about what we do now?
Yeah,
so
we can actually demonstrate what we're actually doing. So.
If you want, we don't have 2 minutes. Okay, so basically before, when it came to the actual abandonment, we did touch upon the fact that when we need assets updated, it goes to a group who would take anywhere, like the presentation said, from 24 hours to almost 3 months to update, 3 years. And it really depends whether it was a backlog or not. So it is a very slow process, and it all depends on how important that piece of asset is that was removed, that was abandoned, and who it affects in particular. Now, versus what we do today, you know.
Well, okay, so here was the question for us. We had an issue with letting our guys delete stuff out on Collector because we don't want to accidentally, you know, pocket delete anything. So our workaround was we actually disabled the delete, and we agreed on a portion of the map where abandoned assets would be moved to, so we still have records of what this asset was. If you actually click into the assets, they would give you a XY positioning that you can use to plot it up if you really still needed to look for it. But by us moving it to an area which is actually our construction yard, that was our workaround to say this asset no longer exists out in the field, but once upon a time it did. So right now that's what we're kind of our shoehorn way of doing it. So.
Okay, do you also collect an attribute that says, you know, that it's been retired, or that it's like an attribute that records that information as well, or is it just the movement of it into your construction area?
We would move it away from the actual area, but we also change the status of it to abandoned.
Great. Well, I think that's about all the time we have today. If we didn't get to your question, please look for the Q&A document. It'll probably take a few days to pull that together and post it. There will be a link to the recording posted to Meetup and GeoNet. If you have any questions about this webinar, please don't hesitate to reach out to me, and I can make sure that I connect you with the right person. Thank you for joining us today.